this lecture, I am going to present what is the basic concept of a structure, classification of structures, assumptions made for the analysis of skeletal structures, classification of forces, and condition of equilibrium. Then coming to the basic concept of structure. Structures are constructed to make easier the performance of various activities connected with residence, office, education, healthcare, sports, transportation, power generation, irrigation, etc. There are variety of structures. Some are monumental structures, some are residential structures, some are commercial structures, and some are recreational structures. All of them have certain common characteristics. They form a system consisting of a load resisting component, which is called superstructure, and a load distribution component to the ground, which is known as substructure. All the structures are designed such a manner that it should sustain the loads coming on them during their service life by possessing adequate strength and also minimize the deformation by possessing enough stiffness. The strength of a structure depends on the characteristics of the material used during the construction, and the stiffness depends on the cross section and the geometrical configuration of the structure. As we know, the primary function of a structure is to receive the load at certain points and transmit them safely to some other points. The structure develops internal forces in its component members known as structural element. The structural engineer to design all the structural elements of a structural system in such a way that they perform their functions adequately. What is the object of structural analysis? The object of structural analysis is to determine the internal forces and the corresponding displacements of all the structural elements as well as those of the structural systems. Then coming to the classification of structures. Structures can be classified in many different ways. One way of classification is based on dimension, such as the skeletal structures, surface structures, and solid structures. The skeletal structure is the one-dimensional structure, surface structure is the two-dimensional structure, and solid structure is the three-dimensional structures. Then coming to the skeletal structures. So this is one-dimensional. It can be idealized to a series of straight or curved lines. And in this structure, the length of the structure is very large as compared with the other two dimensions of the structure. Example of this structure: roof trusses, building frames, and industrial shed. So here this is the truss, this is the truss, this is the Pratt truss, and this is the Warren truss. This is two-dimensional truss, and this is the space truss. This is three-dimensional truss, and this is the plane frame, two-dimensional plane frame, and this is the three-dimensional frame. So this is space frame. So this is space frame and this is three-dimensional frame. And this is the high-rise structure. This is also plane frame or space frame, and here in the case of plane frame or space frame, the horizontal member is called the beam and the vertical member, that is called the column. This is high-rise structure. This is the example of industrial shed. So these all are the skeletal structures. Then coming to the surface structures. The surface structures are two-dimensional structure. It can be idealized to a plane or curved surface. So in this structure, the length and breadth are large in comparison to the thickness. this is the example of the surface structures, that is slabs, domes, cylindrical members and cells. So this is the cell structure, and this is the plate, and this is the cylindrical member, and this is the dome. So these all are the surface structures. Then coming to the solid structures. Solid structures are three-dimensional structures where all the three dimensions of length, breadth and height are equally prominent. So this is the example: foundation, retaining wall, gravity dam. These are the examples of the solid structures. As we discussed, from these three types of structures, skeletal structures, surface structures and solid structures, the skeletal structures can be analyzed by the elementary methods of structural mechanics, whereas the stress analysis of surface and solid structures usually involve the higher mathematics and the theory of elasticity and plasticity. Most of the structural systems are skeletal structures. So coming to the classification of skeletal structures. So there are two types of classification. The first type of classification is pin jointed frame, and second type of classification rigid jointed frame. So first we will discuss what is pin jointed frame. The members of pin jointed frames are connected by means of pin joints. These frames support the applied loads by developing only axial forces in the members. So this is the example of pin jointed frame, truss. This is also called the truss, plain truss. This is pin jointed frame or plain truss, and here these are the members, and this is the joint, and this is the supports. So the support is present at A, this is hinge support, and support at C, this is roller support, and these are the hinge, and these are the members. So the members which is connected at the end by means of hinge. So in the case of pin jointed frame, the frames support the applied loads. This is the applied load by developing only the axial forces in the members. What is the force is acting on the truss, and that force which is registered by the member, the axial forces which is developed in the members. So members carry only the axial force in the case of pin jointed frame. These are the members, so which carry only axial force. This is the resisting force to the applied load. Then coming to the rigid jointed frame, the joints of a rigid joint frames are assumed to be rigid so that the angles between the members meeting at a joint remain unchanged. So here this is the rigid jointed frame. Here this is the angle. So the angle between the members meeting at a joint remain unchanged. These are the joint, and these are the members. This is the vertical members and this is the horizontal members. So here this is vertical member, this is horizontal members, and this is the rigid joint, and here also this is horizontal member, this is vertical member, this is the rigid joint, and this is the support at A and D. So this is the fixed support at A and fixed support at D. These frames resist external forces by developing bending moments, shear force, axial force and twisting moments in the member of the frame. In the case of rigid jointed frame, so this is rigid jointed plane frame and rigid jointed space frame. So in rigid jointed plane frame, the frame which resists the external forces by developing bending moment, shear force and axial force. But in the case of rigid jointed space frame, the frame which resists the external force by developing bending moment, shear force, axial force and twisting moment in the member of the frame. Then coming to the classification of skeletal structures in terms of the frames, so that is plane frame and space frame. There are two types of frame, one is plane frame and the another one is space frame. So plane frame is the two-dimensional structure and space frame is the three-dimensional structure. So first coming to the plane frame. all members of the plane frame as well as external loads are assumed to be in one plane. So in the case of plane frame, all the members and the external load which is acting in the same plane. If the plane frame is pin jointed, then it is known as pin jointed plane frame. And in the case of pin jointed plane frame, the member carry only axial force. Already I have explained this one. So in the case of pin jointed plane frame, the member carry only axial force. If the frames are rigid jointed, it is known as rigid jointed plane frame. The members are subjected to axial force, shear force and bending moment. So this is already I explained. The plane frame, this is pin jointed plane frame and rigid jointed plane frame. So in the case of pin jointed plane frame, the member carry only axial force, but in the case of rigid jointed plane frame, the members are subjected to axial force, shear force and bending moment. This is the example of pin jointed plane frame. So this is the support, hinge support, and this is the roller support, and these are the members and this is the joint. Here the members carry only axial force. And this is the example of rigid jointed plane frame. These are the supports, fixed support, and these are the members, vertical members, and these are the horizontal members. So here the members carry the axial force, shear force and bending moment. Then coming to the space frame. In space frames, all members of the frame do not lie in one plane. The space frames are formed by combining a series of plane frames. If the space frames are pin jointed, it is known as pin jointed space frame. The member of this type of frame are subjected to a axial force. So in the case of pin jointed space frame, the members are subjected to axial force. This is the example, pin jointed space frame, and here this is these are the members and these are the joints, and these are the supports. These are the supports. So here also the member carry the axial force. And if the space frames are rigid jointed, it is known as rigid jointed space frame. The members of this type of frame are subjected to axial force, shear force, bending moment and twisting moment. This is the example of rigid jointed space frame. So here these are the supports, fixed supports, and these are the vertical members, and these are the horizontal members, and these are the rigid joints. These are the rigid joints. So here the members carry axial force, shear force, bending moment and twisting moment. Then coming to the what are the basic assumptions are made in the analysis of skeletal structures. The first assumption, the material homogeneity and isotropy. The material of the structure is assumed to be homogeneous, that is same at all points, and isotropy means the material possesses the same properties in all directions. Then the second assumption, elastic material, that is after removal of the stress, the strain and displacement disappear completely without any residual strains or displacements. So this is the second assumptions made in the analysis of the skeletal structures. Then the third assumptions, the structural linearity. What is structural linearity? As we know, the material in the initial stage behaves linear, that is the stress and strain directly proportional up to certain limit, which is called an elastic limit, and this zone is called the linear zone. Whereas at a higher stress, the behavior of stress and strain is non-linear, that is the strain increases in disappropriate manner as the stress increases. This zone is called the non-linear zone. Here I would like to say, in a linear structure, the stress developed in it are within the elastic limit, and in non-linear structure, the stress developed in it fall in the plastic or a non-linear zone. Such a classification is based on behavior of material. In material non-linearity, the material obeys Hooke's law, that is, the stress and strain both are directly proportional and represented by a straight line. It is assumed that the responsibility of the structure is linear, the load displacement relationship is represented by a straight line, and it is material linearity and geometric non-linearity. In material linearity, the materials obeys Hooke's law, that is, the stress strain curve is represented by a straight line. And in geometric non-linearity, some structures may exhibit non-linear characteristics in its overall behavior due to change in its shape under loading. This kind of behavior of the structure is called geometric non-linearity. The next assumption, that is validity of superposition principle. If the materials homogeneous and isotropic and elasticity and structural linearity is satisfied, then the principle of superposition is valid. So here, for superposition principle, if the material homogeneous and isotropic and elastic material and structural linearity is satisfied, the principle of superposition is also valid. So according to the principle of superposition, the displacement due to the combined action of any two system of forces are equal to the sum of displacement due to the two system of forces acting individually. So this is the assumptions, and this is valid for the analysis of the skeletal structures. Then the next is static equilibrium. This is also one assumption. The structure is assumed to be in a state of static equilibrium under the action of applied forces. The structure is assumed to be in static equilibrium under the action of applied forces. And this is also one assumption, small displacements. The displacement due to the applied forces are assumed to be very small as compared to overall dimensions of the structure. Hence, the geometry of the structure is assumed to remain practically unchanged during the deformations. These are the assumptions which is considered for the analysis of the skeletal structures. Then coming to the classification of forces. The forces acting on a structure may be classified into the following three types. This is the external active forces or loads. Then external reactive forces or support reactions. Then internal reactive forces or stress resultants. These are the three forces, the external active forces or loads. So this is the external load which is acting on the structures. The primary function of a structure is to support certain loads and to transmit them through its member to the supports. So this is the load which is acting on the structure, and this load is transmitting through the members to the supports. So this force is known as the external active force or loads. Then external reactive forces or support reactions. The reactive or passive forces arise are the external supports in order to maintain an overall equilibrium. These reactions are produced as a consequence of applied loads. They disappear on the removal of the loads. The third type of force, this is internal reactive forces or stress resultants. So this force is induced in the structural members. As the consequence of the applied load, every element of the structure is strained. This is the stress resultant. So this is axial force, shear force, bending moment, and torque or twisting moment. So these are the forces which is strained in the member of a skeletal structures. Then coming to the condition of equilibrium, in order to apply the principle of statics to a structural system, the structure must be at rest. This is possible only when the sum of the applied loads and support reactions is 0, and there is no resultant couple at any point in the structure. For this situation, all components parts of the structural systems are also in equilibrium. A structure is in equilibrium with a system of applied loads when the resultant moment about any point is 0. A structure as a whole or any portion thereof is in a case of static equilibrium when the resultant of all external forces acting on it is 0. This condition is satisfied when the sum of the components of the all external forces along any three mutually orthogonal axes and also sum of their moments about these axes are equal to 0. So this is the component of the forces along three mutually perpendicular axes. Summation of fx is equal to 0, summation of fy is equal to 0, and summation of fz is equal to 0. And these are the moments about the axis x, y, and z, and the sum of the moment about these three axes is also equal to 0. Summation of mx is equal to 0, summation of my is equal to 0, and summation of mz is equal to 0. In the case of two-dimensional structure, that is the plane frame subjected to in-plane external forces, so this case only three equations are required for the static equilibrium, that is the summation of fx is equal to 0, summation of fy is equal to 0, and summation of mz is equal to 0. And in the case of three-dimensional structure, that is space frame and subjected to external forces, so this case 6 equations are required for the static equilibrium. So this case we have to use summation of fx is equal to 0, summation of fy is equal to 0, and summation of fz is equal to 0, and summation of mx is equal to 0, summation of my is equal to 0, and summation of mz is equal to 0. So these 6 equations are required for static equilibrium in the case of space frame, and these 3 equations are required for static equilibrium in the case of plane frame. Now all are clear. That is the basic concept of a structure and what is the classification of structures and assumptions made for the analysis of skeletal structures, then classification of forces and condition of equilibrium, static equilibrium.